We're going to look at the graphs of the sine, cosine and tangent functions. So let's look at the graph of y equals sine x first of all. Alright, and you may remember doing this from GCSE level. It's the graph of y equals sine x is a wavy pattern, a wavy function, and it's one that repeats itself. Now we're going to be working in radians a lot. So we're going to be doing sine of particular values on the x-axis which are in radians. So here's my x-axis, here's my y-axis. Right, key points to remember when you're plotting the graph of sine x or you're doing a sketch of it. First of all, remember these 5 key points. 0, the starting point, and pi over 2, which is 90 degrees, so yeah, pi over 2, 90. And then moving on, let's see, that's 4 squares, so here's 4 squares. Pi, okay, so 180 degrees, 3 pi over 2, and 2 pi. These are the same key points on the unit circle. 0, pi over 2 pi, 3 pi over 2. Now let's go through the key values. Sine of 0, okay, 0 degrees or 0 radians, is nothing. So the sine wave starts here, starts at the bottom here in the middle here. Sine of 0 is 0. Right, moving on, sine of sine of pi over 2 or sine of 90 is 1. Okay, now let's say 1 is about here, 1. So 1 up. Okay, there's 1 unit up. So sine of pi over 2 is 1. Alright, moving on, sine of pi is 0. So going back to, so sine of 180 is 0. And then sine of 3 pi over 2 is minus 1. So sine of 3 pi over 2 is minus 1. So let's say that's minus 1 down here. Minus 1. And then sine of, let me do it over here, sine of 2 pi is 0. So it goes back to 0. Right, so the sine function, we say sine wave sometimes, is a wave function that looks a bit like this. It starts at 0, goes up to 1, back down to 0. Okay, this is badly drawn really. Okay, so let me do it here. So, okay, so it goes back to 0 at pi, then goes down to minus 1 at 3 pi over 2, and then goes back to 0 at 2 pi, and it repeats. Okay, so if I copied and paste this, it repeats again exactly the same, and another 2 pi later, so at 4 pi, so it starts at 0 at 2 pi, and then 4 pi later it will be back at 0 again. Okay, and then at 3 pi will be in the middle. Okay, so it'll be crossing the x-axis at 3 pi. So it repeats like this. Now, certain things to remember is that this function, I haven't done anything to it, it's just sine x. And there's key points to remember. First of all, if you look at it, we can sort of chop this wave in half. Okay, we can chop in half from the x-axis. And if we look at the distance away from the middle of it, effectively, let's say this is the middle, the distance up here is 1 unit. So we say the amplitude, okay, is just basically how high this wave is from the middle is 1. Okay, 1 unit up. Right, it's a distance of 1, and it's 1 unit down, even though it's minus 1 here, but it's 1 unit down, right? So the amplitude is 1. Okay, the next thing to look at is something called the period. Now I said to you this wave repeats. It repeats itself. Actually, I've got a bit of software that shows us here. So here's the actual wave itself. Starting at 0, pi over 2 is 1, pi is back to 0, and then 2 pi is back to 0. And you can see it repeats itself again and again, and it repeats itself in the negative axis as well. And it carries on forever, and the height doesn't change. The height's the maximum of 1 and the minimum of minus 1 as well, so that doesn't change as well. Okay, and what it means by the period is the length of one wave. So how long is one wave? Well, the one wave, it starts at 0 and it repeats itself at 2 pi, so the period is 2 pi. So that's the length. It's the length of one complete wave, right? So it starts here, and then at 2 pi later it goes back to the same point, because the period is that. Okay, now the third thing to consider is the principal axis. And what it means by the principal axis, where is the middle of the wave? Where is the dead center of it? Well, that is y equals 0, right? Okay, so here you can see 0 here. Y equals 0 is the middle of the wave. So And that's the principal axis, is the middle of it. Okay, and then let's look at the domain and range of this function, because that's important as well, the domain. So what x values can I put into this function? Well, if you look back at this, it's pretty much any x value you want. So the domain is, oops, that's not very good. It's parentheses look like this, is the x, such that x can be any number you want. Okay, but the range is different. So what y values can this graph have? Well, you can see that it has, the highest point is 1 and the lowest point is -1, and all the values in between, and there's no gaps, but it doesn't go above 1 and it doesn't go below -1. So the range is y, but y is sandwiched between 1 and -1, and it can be any number you want. Okay, so that's the range. Right, let's look now at the graph of y equals cos of x. Okay, cosine of x. Not much difference really from sine of x, just subtle differences. So let's draw our axis first of all. Okay, and here's our x-axis, y. Right, again, same key points you need to consider. 0, let's say that's pi over 2, pi, 3 pi over 2, and that's 2 pi, right? Okay, let's consider these points again. Right, remember, cos of 0 equals 1. So this one starts at 1. So it starts here. So notice the difference. Sine started here, cos starts at the top. Right, cos of, moving on, pi over 2, 90 degrees. That gives you 0. So cos of pi over 2 is, let me do it in orange, is down here, pi over 2. Again, that's pi over 2 is 0. And cos of pi is -1. Okay, so -1 down. Okay, let's try and keep it consistent. 4 squares down. Right, that's -1. Okay, cos of pi is -1. And then cos of 3 pi over 2 is 0. Okay, 0. And then cos of 2 pi is back to 1. So back to 1. So it starts at 1 on the height. Pi over 2 later it goes to 0. And then at pi it goes to -1. And then 3 pi over 2 goes back to 0. And then pi over 2 pi over 2, it goes back to 1. So it repeats itself as well. Actually, that middle bit doesn't look very good. It repeats itself as well, so it carries on forever. So instead of starting at the bottom, it starts at 1, and you can see that 2 pi later it goes back to 1. Right, so let's look at the things again in terms of the amplitude. Right, the amplitude, if you look at it, this is the middle of the function, and its amplitude again is 1. Okay, is 1 unit. From the middle to the top is 1 unit, and from the middle to the bottom is 1 unit. Okay, and then the period. So what's the length of one complete wave? Well, if you look at it, it starts here at 0. It starts at 1, and then 2 pi later it goes back to where it started. So the period again is the same as the sine one. It's 2 pi. Right, the principal axis, so where is the middle of the wave? The middle of the wave, again, the principal axis is at y equals 0. The middle of the wave is y equals 0. And let's look at the domain. The domain is the same for cos as it was for sine x. It's just any number you want, right? Okay, you can put any number in. But the range, again, same as the sine function. It doesn't go above 1 and it doesn't go below -1, so it's somewhere between 1, less than or equal to 1, but greater than or equal to -1. And again, it can be any number you want as long as it's between those two. And let's just check that on here. So let me change this. So option, I need to get my algebra window. Let me change my base function to, I need to right click this. Let me right click it, yeah. Okay, and I'm going to change it to cos this time. Alright, and you can see here we go, 0, it starts at 1, and then 2 pi later it goes back to 1 and it repeats as well. So if I move along the x-axis, you can see it just carries on forever and ever in the same fashion. Right, so that's cos x, and again I haven't done anything to it. Now let's look at the last function. Let's look at the graph of y equals, I'm doing number 3, y equals tan of x. Now remember, tan of x can also be written as sine x divided by cos x, right? They're the same thing, it's an identity. This equals this, right? Now the problem is, well, if you have a fraction, you remember you can't divide by 0. So that's why this particular graph is a bit funny. So let's draw the axis first of all, and we need some negative numbers as well. So I'm going to make the negative side a little bit bigger than before, right? Now let's look at the key points again. 0, pi over 2, pi, 3 pi over 2, and then, no, that's not 4 squares later, that is 2 pi. Okay, and then let's look at just the identical distance the other side, minus pi over 2. Right, here's the funny thing. Because tan x is the same as this, remember you can't divide by 0. Okay, but if you go back up, when is cos x 0? Cos x is 0 when you make x pi over 2. Or 3 pi over 2. Look, here we go, 0 there, and then 3 pi over 2. So what happens is we have some asymptotes, because we can't divide by 0. At pi over 2, we have a vertical asymptote, and at 3 pi over 2, we also have a vertical asymptote. And then at minus pi over 2, we also have a vertical asymptote. So it's not going to touch any of these lines. It's going to get really close to these, but it's not going to touch. That's because cos of pi over 2 is 0. And you can't divide by 0, right? And cos of 3 pi over 2 is also 0. And cos of minus pi over 2 is also 0. So you can't divide by 0. So we have got these vertical asymptotes. And this is what the tan function looks like. It gets really close to this line. It gets to 0 because sine of 0 is 0. And then it goes close to the asymptote here. And then it repeats like that. So it's going to look identical here. Oops, I haven't done that very well. It needs to go through pi. And then if I, well, let's say there's pi over 2. If I add another half pi, which would be, so adding pi over 2 to 2 pi would give me 5 pi over 2. There's another vertical asymptote here. And it looks, it'll look like this. And it just repeats in that fashion. So let's actually change it on here. If I can, So I need to change it to tan. And you can see, well, we've got our asymptotes of pi over 2, minus pi over 2, and 3 pi over 2, and it repeats like this forever and ever and ever. So when you're sketching tan, cos, and sine, remember these key points. Okay, now let's look at the key points to do with the tan function. First of all, the amplitude is irrelevant here because it just carries on forever. It gets larger and larger and larger at pi over, when it gets close to pi over 2. But the period for this function is different. You can see it repeats itself. Well, what's that different distance here? It kind of repeats itself. Well, pi over 2 to 3 pi over 2, that's a distance of pi. So the period for this is pi. And the domain, well, you can put any number in apart from pi over 2. You can try it yourself. If you did tan of pi over 2, it'll come back with an error. So it can't do plus or minus pi over 2. So hang on, it needs to be x doesn't equal pi over plus or minus pi over 2 or plus or minus 3 pi over 2. But the range is the whole of the y-axis. It can be any number. And they're the three functions. Okay, we're going to build on this